Fighter jets are amazing feats of engineering. They zoom through the sky faster than the speed of sound. These jets have changed how we think about air travel. What once seemed impossible is now routine. Early airplanes were slow and clunky. Fighter jets brought speed and agility. This revolutionized air combat. It also pushed the boundaries of what we thought was possible in the air. The quest for faster and more maneuverable fighter jets led to incredible technological advancements. These advancements have applications beyond the battlefield. They influence everything from commercial aviation to space exploration. The story of fighter jets is a story of pushing limits. It's about reaching for incredible speeds and achieving what was once thought impossible. But how do these advancements translate to the vastness of space? Let's take a closer look. 3 key technologies make fighter jets so remarkable: powerful engines, lightweight yet strong materials, and advanced control systems. These technologies are essential for achieving high speeds and maneuverability. Jet engines create massive thrust. This allows fighter jets to reach supersonic speeds. These engines are marvels of engineering. They generate immense power from a compact design. Advanced materials like titanium and carbon fiber are crucial. They make the jet strong but light. This strength-to-weight ratio is essential for withstanding the stress of high-speed flight. Finally, sophisticated control systems allow pilots to handle these powerful machines. These systems are highly responsive. They help pilots execute complex maneuvers and maintain control at supersonic speeds. These technologies work together seamlessly. They make fighter jets a testament to human ingenuity and our constant desire to push the boundaries of what's possible. Fighter jets are fast, and they represent some of the most advanced engineering on Earth. These machines are designed to slice through the sky with incredible agility and power, making them the kings of our atmosphere. They can reach speeds several times faster than the speed of sound, creating dramatic sonic booms as they break through this invisible barrier. The speed of sound, also known as Mach 1, is about 767 miles per hour at sea level. That's already much faster than most vehicles on the planet. Some advanced fighter jets can travel at over 1,500 miles per hour, or roughly twice the speed of sound. That's incredibly fast, and it takes a lot of technology and training to control such speeds. However, when we look at space travel, we enter a whole different ballgame. The requirements for leaving Earth are on a completely different scale. To escape Earth's gravity and reach orbit, spacecraft need to travel much faster than any jet ever built. The forces involved are immense, and the technology is even more advanced. The minimum speed needed to reach orbit is around 17,500 miles per hour. That's called orbital velocity, and it's what keeps satellites and space stations circling the Earth. That's over 10 times faster than the speed of sound, and more than 10 times faster than even the quickest fighter jet. While fighter jets are incredibly fast in our atmosphere, they are nowhere near fast enough for space travel. The difference is truly staggering when you see the numbers side by side. The speeds required for space travel dwarf even the most advanced fighter jets' capabilities, making rockets the only vehicles capable of reaching the final frontier. This difference in speed highlights the immense challenges of space travel, and why it remains one of humanity's greatest achievements. It requires overcoming gravity, a force far greater than anything encountered within Earth's atmosphere, and demands technology and power on a scale that's hard to imagine. Space travel presents a lot of challenges. It's not just about building a rocket and blasting off. There are layers of complexity that make every mission a massive undertaking. From the moment a spacecraft leaves Earth, it faces a whole new set of problems that engineers and scientists are still working to solve. Distance, fuel needs, and safety are, honestly, some of the biggest concerns. Each one is a puzzle in itself, and together, they make space travel one of humanity's greatest technical challenges. So, can fighter jet technology help us overcome these obstacles? Fighter jets are marvels of engineering, pushing the limits of speed and maneuverability here on Earth. But space is a whole different ballgame. While distance is a huge problem, the scale of space is almost impossible to grasp, even for experts. Space is just, vast. Even our own solar system is enormous, and that's just a tiny corner of the galaxy. Even the closest star to our sun is trillions of miles away. To put it in perspective, if Earth were the size of a marble, Proxima Centauri would be another marble over 4,000 miles away. With our current spacecraft, it would take tens of thousands of years to reach even the nearest star system. That's longer than all of recorded human history. Now, fuel is another issue. rockets need to carry every drop of fuel they'll use, and that creates a huge engineering challenge. Spacecraft need a tremendous amount of fuel just to escape Earth's gravity. The energy required is mind-boggling, and every extra pound makes the journey harder, and carrying all that fuel adds weight, which makes it even harder to reach high speeds. It's a vicious cycle. More fuel means more weight, which means you need even more fuel. Safety, of course, is always paramount. Every mission is planned down to the smallest detail to protect the crew and the spacecraft. Space travel is, by its nature, risky. There's no room for error when you're millions of miles from home. Radiation, micrometeoroids, and the vacuum of space all pose serious threats to both spacecraft and astronauts. Even a tiny piece of debris can cause catastrophic damage at high speeds. While fighter jet technology gives us valuable insights into high-speed travel, it alone simply can't solve all the challenges of space travel. The conditions in space are far more extreme than anything jets face in Earth's atmosphere. We're going to need even more innovative solutions to really conquer the final frontier. The future of space travel will depend on breakthroughs in propulsion, materials, and maybe even ideas we haven't dreamed up yet. Despite all these challenges, fighter jet technology has actually influenced space exploration in several important ways. The development of lightweight materials, for example, has been crucial for building modern spacecraft. Take the Space Shuttle as an example. It used heat-resistant tiles that were originally developed for protecting supersonic aircraft. These tiles were absolutely essential for the shuttle to withstand the intense heat of re-entering Earth's atmosphere. Similarly, the control systems used in fighter jets have inspired how we design spacecraft navigation systems. Being able to make precise adjustments at high speeds is critical for both fighter jets and spacecraft. And while the basic principles of propulsion and aerodynamics are different between air and space travel, the pursuit of speed and efficiency in both fields has led to some really fruitful technological crossovers. So, can fighter jet technology alone actually lead to faster space travel? It's a question that captures the imagination of anyone who's ever watched a jet streak across the sky or dreamed of exploring distant stars. Well, the answer isn't really straightforward. The connection between fighter jets and space travel is more complex than it might seem at first glance. While jet technology has, indirectly contributed to space exploration, it's mostly through advances in materials, aerodynamics, and control systems that have been adapted for rockets and spacecraft. The extreme conditions of space, like the vacuum and intense radiation, require a totally different approach than what works within Earth's atmosphere. Fighter jets rely on air-breathing engines, which are designed to suck in oxygen from the atmosphere to burn fuel and generate thrust. But in the vacuum of space, there's no air to breathe, so these engines just won't work at all. That's why rockets, which carry their own oxidizer, are used for space travel. Plus, achieving the kinds of speeds needed for interstellar travel, speeds that would let us reach other star systems in a human lifetime, like what you see in science fiction movies and TV shows, would require entirely different concepts like warp drives or other exotic propulsion systems that go far beyond anything we have today. And those are still purely theoretical, existing only in the realm of advanced physics and science fiction for now. Still, the relentless pursuit of speed and efficiency in designing fighter jets continues to inspire innovation, pushing engineers and scientists to think bigger and bolder. The lessons we learn from pushing the boundaries of aerial technology could spark breakthroughs in space travel down the line, as new materials, control systems, and design philosophies are developed. We might not be reaching warp speed with jet engines anytime soon, but every step forward in aviation brings us a little closer to new possibilities. The spirit of innovation and pushing limits, which is at the heart of fighter jet technology, really embodies humanity's drive to go faster, farther, and higher than ever before. And who knows? That same spirit will definitely keep fueling our dreams of exploring the cosmos, maybe even at warp speed one day. To achieve significantly faster space travel, we really need to look beyond just conventional jet technology. Here are a few areas where breakthroughs are needed. First, new propulsion systems. We need engines that don't rely on traditional chemical rockets. Ideas like ion propulsion, nuclear fusion, or even antimatter propulsion are being explored. Second, understanding gravity. Manipulating gravity could hold the key to faster-than-light travel. While that's still in the realm of theoretical physics, concepts like warp drives and wormholes offer some pretty tantalizing possibilities. And third, investing in research, Advancements in space travel require significant investment in research and development. Both government funding and private sector innovation are absolutely crucial for pushing the boundaries of space exploration. Faster space travel isn't going to happen overnight. It'll take time, dedication, and a real willingness to explore unconventional ideas.